Welcome to Java Minds. In this video we will learn what is comparable and comparator and where to use what, and also we will learn how can we use streams for sorting using comparator interface. Nowadays interviewers are asking what is the difference between comparable and comparator. This is a straightforward question they are asking for some 3 to 4 years of experience people and also for freshers. And if you have more experience, they don't ask like this, they ask indirectly. They will give a situation and they will check our knowledge whether we are approaching to comparable and comparator to accomplish that requirement. Okay, so for a Java developer it is very important to know comparable and comparator and where to use what. Okay, let's dive into this. So let's say generally in real-time applications we get data from database, lot of data we'll get, and generally we store that data into the list, right? Let's say I got a list. Let's take some employee list. Let's look at this. Yeah. So keep it here. Yeah. So let's say we got this list from database and we got a requirement to sort this employee list based on this employee ID. Let's go through this employee class once. So employee has, let's say, ID and name. Okay, ID and name, and we have getters and setters and 2 strict method for displaying purpose. And they may ask us to sort based on these IDs. Normally these are identifiers, right? We won't display in the list in the UI normally, but they may ask us to sort based on the names. Let's say they want to display based on in the ascending order of the names. Let's say Akhtar should come first, then second what should come? I, right? Like that. So anyway, so maybe we have to learn this sorting either based on ID or based on name. So the sorting we have to do here ideally, basically. So how can we do sorting of list? Normally we have a method in the collections class. When we learn Java for the first time, we will learn a utility class called collections. When we go through the collections topic, we will learn collections class. Okay, so in the collections class we have so many utility methods, and one of the utility methods is sort method. It presents in util java.util package, and we have a sort method. And to the sort method, if we pass this employees list, it will sort it, the same list, whatever the list we are passing, it will sort it. So we can pass like this. Can you see now we are getting some kind of compile time error is not applicable for the arguments. So actually it is checking whether initially only, before running it only, during the compile time itself it is checking whether I am able to sort it or not. So it knows that it cannot sort it. Why? Because the sorting logic we have not provided to it, right? The sorting logic we have not provided to this. Based on what criteria I have to sort, it doesn't know, right? So we need to provide some kind of sorting, some kind of default sorting logic for this employees object, right, for this employee class, so that whenever we want to sort anywhere, by default some sorting order, it is able to sort. So how we can provide that logic? Normally in real time, when we want to define some default sorting order or some natural sorting order for a class, then what we do is, here we'll implement an interface called comparable, right? So it is a generic type. What we are comparing, that type we can pass. Here I am comparing employee class, so I can pass employee type. So I am comparing employee object, so I can pass employee type. So we need to implement one method called compare2 method. So this method we need to implement, right? So how that logic works, you know, some kind of logic we provide here. What is it is, for sorting order for sorting in ascending order, take the current class, current object, that is this dot id. For example, I am sorting based on id first, less than e dot get id. So if if I am taking the current object id first, right, if it is less than that, whatever the next object I am passing to this method, if it is less than this, then we need to return some negative value. Then it will comes first, whatever the current object is there, that will come first, then second, the whatever the second object which we are passing to this, that will come next. Else if I'm copying this, if it is greater than this, then return the positive value. Otherwise, if both are same, you can return the 0. So this is how we can do it. Or we also have in integer compare method, that also we can do it. So instead of doing like this, it will work anyway. So in integer we have a compare method also, that also we can use this. In most of the times we don't write like this. Instead of writing like this, I save my time. What I will do is, integer, where it is in Java lang, no need to import, integer dot compare. What I want to compare, this dot id and e dot get id. It's very simple, right? We have saved a lot of code, time also. If you do like this, we can save time. That's it, it will take care. So here what I am doing, I am implementing comparable interface for natural sorting order. It defines, this is the behavior of this employee class. Whenever if I try to sort employee, then by default it utilizes this comparable, and it will sort based on this logic provided here. It is a default and natural sorting order. So now see, error is gone now, compile time error. So we can run it now. So we are getting some kind of exception, unsupported operation exceptions and immutable collections. So we have created a list with a list, right? Do you know this? Whenever we define a list with like this, it is an immutable list, it will return an immutable list, and we are trying to modify the immutable list, so we will get unsupported operation exception. So just what I will do is, here I will make it mutable. I will wrap it with array list, so that array list is mutable, right? Yeah. Anyway, let me import it. Yes. Let's run it. Yeah, it's sorted. It won't return. We are not printing it, right? Yeah. So we will print it. Employees dot stream dot for each, right? Each employee I will print in each new line. System dot out colon println. It's a method reference I'm using here. Yes. So 1 3 4 5. So now it is able to sort, right, with based on the IDs, right? So this is a default natural sorting order I provided to the my employee class. Okay, this is fine. So whenever we want to sort, we are able to sort with this. But tomorrow I will get one more requirement in some other place, because it is a very large code base. We may sort employees based on our requirement. Maybe I may sort based on the sorting order of ID, and I may need to sort it in descending order in some other place. Maybe in some other place I may need to sort based on the names, and we will have different requirements, right? Then in that case we need to customize the sorting order. So this is, I am using the comparable, right? This is, I defined it for the first time. By default it will work. Whatever the implementation we have provided here, by default it will work like using this. But tomorrow I have to customize it. I need a different requirement. I have a different requirement. So in that case what we will do, we will approach some other concept called comparator. So that is another interface provided by Java. If you want to customize, you can use the comparator. If you want to define some natural sorting order, you can use comparable. So that is the difference between these two. When interviewer asks you what's the difference between comparable and comparator, this is the first answer we have to provide. Comparable we use for defining natural sorting order. Comparator we use for customizing the sorting order. So that is the main key difference between these two. Okay, so comparator, how to do it? Normally in before Java 8 we used to define a new class, custom class implementing the comparator interface. We will implement it here. We will see now. Let's say I want to sort this one based on the names, let's say, or descending order of this, anything is fine. I will do based on my names. I want to sort based on the names. So employee name comparator, let's say. Okay, let's implement comparator. Implements comparator. And what we are comparing, the type here, employee we are comparing, right? So let's implement. So it has a compare method. Do you see? In employee we have a compare to method, but in comparator, in employee we have compare to. We are extending it, right? We are overriding compare to method from the comparable interface. Here comparator, what method it is providing? Compare method. So this is also one difference. If you want to tell more about the difference between these two, we can also tell in comparable we have compare to method taking one argument, and in comparator we have compare method taking two arguments. This is also one difference we can say if you want. Now again I want to compare, right? What I will do is I want to compare names, right? Yeah. So what I will do is, again in string class, in string we have compare method that I will use. O1 dot get name dot compare to, and O2 dot get name. So what it will do is, it will by default it will do ascending order, it will do of the names. Okay, so this is a customized way of doing. Now for the same employee class, by default employee, by default the natural sorting order is based on the ID, but I got a requirement to sort based on the name. This time I want to implement logic, a custom logic. I want to create a new class, comparator class, and I want to implement the comparator interface to provide some customized sorting order, right? Let's try now what will happen. So this same sort method I want to now sort using names. So how we can do is, sort is an overloaded method in collections class, so it will also accept comparator instance. So that is new employee name comparator. We can pass like this. Done. So let's run it. Yes. Can you see now? A comes first, Akhtar, Iris, John, Mahesh. So it is sorted based on the names. So this is how, this is what the difference, the key difference between comparable and comparator. If interviewer asks the difference between comparable and comparator, we can easily answer. Comparable interface is meant for natural sorting order. Comparator is meant for customizer sorting order. And comparable interface contains compare to method. Comparator interface contains compare method, right? And comparable, we implement whatever the class we are sorting, that class itself implements comparable, but for comparator we need to create a new class, additional class, right? So these are the differences between comparable and comparator. We can easily answer. But now in Java 8, after Java 8, I stopped implementing comparator interface using the class like this. And also so many people stopped implementing even comparable interface also, because whatever the comparing logic we want, we can provide it using the functional interfaces, that is using lambda expressions or method references. So some methods are provided from the stream API to implement the comparing logic in the streams itself. So after that, Java 8, so the approach got changed. So we will see the same thing I can accomplish using streams. We will see that. Okay, but still we need to know the difference between comparable and comparator. Okay, those are not deprecated, remember. So now what I will do is the same, I will do sort based on the IDs of this employee. So for that, what I will do is I will just remove this. Otherwise we will take a new class. Okay, for this let's keep it, and I will take another list called product list. Okay, I'll just replace it with here. So anyway, so we have a product class defined here. It has some ID, name, availability, price. It has one all args constructor, and it has some getters and setters, and toString method for displaying purpose. So now I want to do sorting. So anyway, these are in sorted order, but I want to do in reverse. I can sort based on the IDs, I can sort based on the prices, I can sort based on the availability, I can sort based on the names, I can do anything. Or I can do sort based on the combinations. Let's say I want to sort based on price, and then if the price is same, I can sort based on the availability, and if the availability is same, I can sort based on the names. The different of logic also I can provide in the streams API. We will see now. We will see one basic thing. We will take this product list dot stream dot sort. So we have two methods here, sorted and sorted comparator. If we take sorted without anything, then we need to provide comparable and comparator. For that, comparable we need to provide, we need to implement comparable interface, otherwise we will get exception. This will work with comparable. Okay, sorted, then to list. So where list. Okay. Let's say this is sorted list. So this one also we can use if you want to use natural sorting order. Okay, let's say if you take employee list, employee is already implementing comparable, right? So I can use employee list here, but here I am not using comparable, right, for product class. What will happen we will see now. Okay, we will get runtime exception, right? What we are getting? Class cast exception. It is trying to cast to comparable, but our product class has not implemented comparable. So if you want to use sorted for natural sorting order, we must implement comparable. But without implementing comparable also we can do, but in that case we need to provide the comparator, that implementation. How we can provide? We no need to create a new class called implementing comparator here, but directly we can provide the logic here itself. How we will provide, we will see. Comparator, right? In comparator we have comparing method, and in this comparing method I can provide any one field for which I want sorting. Let's say I want to sort based on availability. Yes, what I will do is I will provide availability method, product get availability. That's it. Now see, yes, so products got sorted based on the availability. 10 is coming first, 20, 30, 40 and then 50, right? They are sorted based on the availability. Okay, so this is how we can do. Let's say I want this, if you are providing like this, but how it is doing sorting based on the ascending order. For example, I want to do it based on the descending order. What I can do is, in the comparator itself, after doing this, after comparing method, here what you can do is you can call reversal method. So it will do reverse of this. That means it will do sort based on the descending order. Right, see, 50 comes first, 40, 30, 20, 10. Right, interesting. Okay, this is fine. I am doing like this. But here, what if the price is same? Sorry, what if the availability is same? If the availability is same, I want to sort based on maybe name or maybe price, anything, right? Let's say price. For that, what I will do is I will just make availability same. For example, let's say here 40, this one also I will make 40. Okay, and in that case what should come first is, okay, for now what it is coming we will see. So 40 is coming. In this case I want to sort based on price. That means lower price should come first, something like that, any logic. So what we can do is, after doing sorted this like this, I will move to the next line. Then comparing again, then comparing I can do. In then comparing, what I can do, product based on what I want to do, price, right? That's it. See, for the same availability I am sorting based on the price. So this is how we can provide the customized logic in the using the functional interfaces like this, in using the dynamic expressions, using the lambda expressions, or you can say here method references we are using. So this is how you can do it here itself. If you do like this, is it required to implement comparator class separately? Not required. Even is it required to implement comparable also? Not required. I don't do, because I can do even whatever the default natural sorting I want to use, that sorting I can provide here itself. But still, if it is already implemented, if it is already implementing the natural sorting order using comparable, simply you can call sorted, no need to provide comparator here like this, right? So anyway, so this is how we can use stream API for sorting also. Okay, I hope you understood the difference between comparable and comparator interfaces, and also you understood how we can use comparator sorting logic using stream APIs, using comparator logic like this, right? Yes. And one more thing, you are actually comparing what here? Availability means what? Availability is a which data type? Availability is int data type, right? So whenever we compare int, we have a method called comparing int. We can do this because it will improve the performance, because it doesn't know what is the number, what is the type we are passing. But if you say comparing int, it knows that okay, I am passing int, so it will perform faster than comparing. That if you provide directly like this, it has to convert, it has to verify what type of it is, what type it is, then accordingly it has to perform the logic. But if you do like this, it will directly, it knows that okay, I am passing the int value, so directly it will start sorting it, so it will improve the performance. Here what I am doing, price is double, right? So comparing double, you can pass like this, you can call comparing double method. So this type of methods will improve performance a lot. Okay, so this is the best practice to use these methods. Whatever comparing, whatever the type we are comparing that corresponding method, it is better to call to improve performance. Okay, still it will work. So it is doing sorting based on availability in the descending order. Then if availability is same, it is sorting based on the price in the ascending order, right? Okay, thank you for watching. Please like, subscribe and comment. Bye bye.